Hey, it's Sam, and today I'm going to be showing you another Arduino project. So lately I have taken up an interest in speedcubing, which for those of you who don't know is a sport, if you want to call it that, of who can solve a Rubik's Cube and other similar puzzles the fastest. So in order to help myself improve, what I've made is a timer. For those of you who know about cubing, you know there's a thing called a Stackmat timer, which I'll show a picture of. But basically, one puts their hands on it, reaches out, solves the cube, and then puts their hands back on the timer, and the timer stops when they put it down, and it starts when they put their hands, and then they take their hands off the timer. I don't have a Stackmat timer because that would cost $35, I think it is. So instead, what I did is I made my own timer with an Arduino and some other electronics, and that's what I'll be showing in this video. So first I will start by showing how it works. I will do a solve with it, and then I will explain how it works, showing you the components and code. So let's plug it in. So what it shows first is a scramble in cube notation, and I'll just pick up my cube and do that scramble. Okay, so this is the scramble. This is it. And now what I do is after I've placed it in front of the timer, it tells me to inspect the cube. So I pick it up and I'll inspect it, and as you can see on the camera, there is a countdown of numbers on the right to inspect, and I'll inspect the cube, and well, now I'm ready to solve it after I've inspected it. So what I do now is I put the cube down, and as you can see, the red light turns on when I put the cube down, and it shows me how much time I had left when I was inspecting. Now what that red light tells me is when I pick up the cube, it's going to start the timer. So I'm just going to grab the cube and the green light will turn on. The green light is right here, and that is when the timer will start. Here we go. Alright, so when I drop the cube, now the timer has stopped, the lights have turned off, and as you can see, I got a time of 56.43 seconds. For me, that's a decent time. Now, I will go into explaining how the timer works. I'm going to talk about all the hardware in the circuit. This is an Arduino Nano, and it is plugged directly into the breadboard. It's powering both power rails with the ground over here, and then 5 volts and ground over here. There's no 5-volt pin on this side of the Arduino Nano, so in order for this rail to get 5 volts, it has to be transferred from this rail with this long gray wire. There's 2 LEDs here which you saw signaled when to start solving and when you should be solving, and they both have resistors so that they don't get blown out. This ultrasonic sensor is a HCSR04, and it is just constantly looking for the cube. And then possibly the most flashy part of the circuit is this LCD, liquid crystal display. It's 16 by 2, so 2 rows and 16 columns. And it is controlled by through I2C. This chip right here was soldered onto the LCD so that I can control the LCD using only 4 pins: the VCC, ground, SDA, and SCL. SDA and SCL are used to send data to the LCD. Well, before the LCD, this chip right here, and it'll interpret that data and then send it to the LCD through these pins. If I didn't have this I2C connector, then I would have to use almost all of these pins instead of now where I only have to use 4 pins. So that really helps me, 1, make the circuit look a lot cleaner, and 2, make less connections, which takes a very, very long time, and 3, just simply use less pins on the Arduino, which means that if I ever want to add something more to this, then I can have more room instead of being restricted because this LCD takes up too many pins. Before I move on to explaining the software, I think it'd be a good idea for me to show you this circuit schematic. Now, I used a fairly basic circuit schematic maker to make this, so it did not have all the components that I have in the circuit, so I'm just going to clarify what components are incorrect. This LED right here should be green. It is red, but when you're making it, unless you want 2 red LEDs, you should have this as a green LED. These 2 resistors, say they are 220 ohms, they should be 330 ohms. And this is a LCD, but it does not have the I2C connector on it. So this first pin to the left here is the ground pin. The second pin is the VCC pin. This third pin is the SDA pin, and this fourth pin is the SCL pin. And for the Arduino Nano, there's no cable or power module running to it, so just make sure that if you use a battery pack like I demonstrated, have the power module to control the power supply, and if you're plugging it directly into your computer, it's a mini B USB that you have to use. One more thing about the hardware. When you are solving the cube using this timer, make sure the ultrasonic sensor is pointing away from you, as in you put the cube in front of you, in front of the timer. And it is important that you do this. The first reason is simply for practice. A Stackmat timer, you have your hands beside the timer and you drop the cube in front of the timer, not behind the timer. So that will help you practice for using Stackmat timer. And then the second reason, which is extremely important, is because of hardware. Because things don't work as they should in theory. So something I discovered is when I was solving the cube, sometimes mid-solve, the timer would just stop. And I was confused because my cube is way back here. I should not be in range of the ultrasonic sensor. And indeed I wasn't. I moved around all over here, shook my hands, and it didn't stop. And then I just thought, okay, well, the ultrasonic sensor works with sound, right? It works like bat's echolocation. Sends out sound and then listens to that sound. So what if it's listening to a sound and it thinks that that's what it's supposed to be listening to? And I thought, well, what makes noises right in front of the ultrasonic sensor? Well, the cube, of course. I mean, I'm solving the cube right here. So then I did some turns on the cube, tried to do some really loud turns, and I found that, yes, occasionally the ultrasonic sensor would confuse the noises coming from the cube as the echoes that it sends out and is supposed to be listening to. So it would stop the timer prematurely. So make sure that the timer is facing, or the ultrasonic sensor part of the timer is facing away from you, and you put the cube in front for practice and for consistency in use of the timer. The code explanation ended up being very long, so I've decided to have a separate video only for the code explanation. So if you would like to see that code explanation, then hit the card in the top right corner and you'll go there, and there you'll be able to see how the code works and also figure out how to use this code for yourself. This is the end of the video. I have explained everything about this timer. Now, if there's anything you think I should do to improve the timer, or do you think there's another Arduino project that has to do with cubing or not even cubing, if there's anything you think I should do in future videos, or if you make this timer, then tell me in the comments or in my Discord. There'll be a link to my Discord in the description, and you should join it, and tell me what you think I should do next there. I'll see you in the next one.